Hi everyone, this is Mrs. Musoff here, and we are going to learn our fourth method for solving a quadratic equation, and that's using square roots. So that's the goal for today, so solve quadratic equations using square roots. Now we've learned three other methods before this, alright, let me just remind you of them. We've learned how to solve by graphing, and that was on the calculator. But remember, that only worked when we had real solutions, and it only gave us decimals, no exact answers, right? So there were limitations. The second method we learned was by factoring. But again, that only works with real solutions and not all real solutions, because decimals would mean it wasn't factorable, right? So I couldn't solve it by factoring. And then the third method we learned was the quadratic formula. And that one worked all the time for every quadratic that we had. Alright, so this fourth method that we're learning, square roots, that is not going to work all the time. We only have two methods that always work, the quadratic formula and one other one that we're going to learn later. So solving by square roots only works when there's only one x in the equation. When there's only one x. So just to give you an example, what I mean by that, because it is quadratic, so it still has to be a squared function, x squared. But here's an example, right? An equation like this. Right? That is still an x squared equation, so it's still quadratic, but because it only has the one x, we could solve it by square roots. Right? A non-example, just so that you can have kind of a comparison, right? Something like maybe this, right? That would not be a problem that we could solve using square roots, because even though it is x squared, there are two different x's, and we can't solve with square roots when there are two different x's. Okay? Now, when it comes to solving by square roots, there is an important rule, and I'm going to kind of walk you through it so that hopefully you can recognize where it comes from. So when you see the square root of 9, what that really means is what number, if you square it, will give you 9. So can you think of a number like that? What number, if I were to square it, will give you 9? So in other words, x, if I were to square it, will give you 9. What could that number be? Well, hopefully you thought of 3. Right? 3, if I square it, would give me 9. But can you think of a second number that would work? How about negative 3? Right? 3 squared, we know, would give us 9. Well, remember, we've talked about this before. If I square negative 3, that's negative 3 times negative 3, that's also going to be a positive 9. So what happens when we do these square roots inside of an equation is you end up with two solutions. You end up with a positive solution, and you end up with a negative solution. So something that's going to show up every time that we do square roots, the important rule, is that as soon as you take the square root of something in an equation, you need to put that plus or minus in there. And that's what this symbol is. So plus for the positive, minus for the negative. Alright, so let's take a look and I'll show you some examples. So for these, we're going to solve using square roots. Now, the number one rule when we're solving with square roots is whichever part is squared, we want to get that part alone. So like in number 1, this says x squared minus 16 equals 0. The x squared part, I'm going to try to get by itself first. So that means any numbers with it, like this minus 16, I'm going to move it over. Alright, so I get 0 plus 16, that's 16. Now, once the squared is alone, like it is right here, that's when we actually use the method, right? Solving using square roots. So, to get rid of a square, I'm going to use a square root, and I'm going to do it to both sides, because whatever you do to one side, you got to do to the other. Okay, but what happens here, this is the golden rule of square roots, is because I took the square root of both sides, the square root and the square, those just cancel out. Right, but on the other side, the square root of 16, that's saying what number, if I square it, would give me 16. And there are two options. There's positive and there's negative. So as soon as you square root something in an equation, throw that plus or minus down. Alright, so what I end up with here is just x, because the square root and the square are inverses. They cancel each other out. And then I have plus or minus the square root of 16. And since x is alone, all that's left to do is simplify the square root of 16. Right? You can break it down, factor it out, or maybe you recognize what the square root of 16 already is, which I hope a lot of us do. If you were to break it down, you get 2 pairs of 2. One of each of those comes out, so that's 2 times 2, which is 4. And we know the square root of 16 is 4, so that makes sense. So I end up with my 2 different answers because there's a positive 4 or a negative 4, plus or minus 4. And that's it. Okay, let's try a little bit of a harder one. So in number 2, we have 2x squared plus 1 equals 17. So again, I want to get the squared part by itself. Now be careful. What's actually being squared here? All right, when there are no parentheses and you see a squared, that squared only applies to what's immediately next to it. So that 2 is not part of the x squared. Just the x is being squared. So that's the part that I want to get alone. So again, I'm going to try and get rid of the 2 and the plus 1. We always get rid of addition and subtraction first. So I'm going to subtract 1. 17 minus 1, that's 16. And then I am going to get rid of this 2 before I keep going, because again, I'm trying to get this part by itself, not the 2, that's not part of it. Okay, if there are parentheses, it might be part of it. No parentheses, not part of it. So I'm going to divide by 2 to get rid of that 2. So now we have x squared equals 8. And once the squared is alone, once again, we are going to square root both sides. And because I square rooted both sides, the square root and the square cancel out. But I have to remember my plus or minus, because that produces 2 answers, positive and negative. So we end up with just x on the left, and on the right, I have plus or minus the square root of 8. Now, is 8 a perfect square like 16 was in the first example? No, it's not. So I am going to have to break this down and rewrite it as the simplified square root. So 8 turns into 2 and 4. And 4 will give me 2 and 2. So I have 3 2's. I only want pairs, so there's my pair. I'm going to cross out one of them. Now the plus or minus goes in front of this simplified square root. So I'm going to put the plus or minus first, and then that 2 comes out. And the one that's left over stays inside. So we have x equals plus or minus 2 root 2. And remember, you've got calculators, so if you ever get a little unsure of yourself, feel free to type it in your calculator and check to make sure it works. All right, you would just have to check the positive and the negative version, and you would have to remember to use parentheses in order to substitute it. All right, a few more examples. So number 3, same idea. All right, I'm trying to get my x squared self, so I'm going to subtract 20 from both sides. And that'll give me just x squared on the left, and 0 minus 20 is negative 20. Now again, I am going to square root both sides. Square root and the square cancel out, and I have to remember the plus or minus on the other side. So we have x equals plus or minus the square root of negative 20. And then again, I have to simplify my square roots always. We didn't spend, part of day 3 simplifying square roots for nothing. We did it so that we would remember to do it later on. So make sure you simplify the square root. All right, the negative means I'm going to bring out an I, and I'm going to put it right next to the root. Right, not in front of the plus or minus, right next to the root. And then I'm going to break down 20. So 4 and 5, 2 and 2. So I have a pair of 2's. That 2 is going to go with my I. So plus or minus 2i. And the 5 that's left over is going to stay underneath the root. So I end up with my 2 answers. X equals plus or minus 2i root 5. All right. Number 4 is pretty similar. So I want you to try that one on your own. But I'm going to write the answer down for you so that when you do try it, you can kind of check to see if you're doing it right. And if you get a completely different answer, then you know to definitely look it over and ask about it when we get back, when we start talking about this again in class together. All right? So this is what we should get for our answer. Whoops. X equals plus or minus I root 17. So check it out. Try it. If you want to see the steps, they're up on the filled in notes that are on Canvas. Okay, now let's go ahead and flip it over because there are some problems that are just a little bit more challenging that we want to make sure we understand how to do. All right, 5 and 6, the main difference here is that now instead of just x being squared, there's a number inside the parentheses that's also being squared. But the general rules are still the same. Whatever is being squared, that's the part you want to get alone, right? Get it isolated, and then get rid of the square. So for example, in number 5, it's x plus 10 that's being squared because of the parentheses. So that's the part I want to get alone. Now here, it's already alone, so I can go straight to my square root. So I'm going to square root both sides. Remember, square root and a square cancel out, and I have to remember my plus or minus. So the only difference here is now it's x plus 10 that's coming down instead of just x. And then plus or minus, the square root of 90. And I would simplify the square root of 90, right? Break it down completely, 9 and 10, 3 and 3, 2 and 5. Your pair comes out, the leftovers stay in and multiply, so 2 times 5 is 10. So we get 3 on the outside, root 10 on the inside. Okay. Now the biggest difference between these problems and the other ones we did is that we're not quite done, because I want to get x alone, right? That's what solving for x means. And right now it doesn't say x equals, it says x plus 10 equals. So the very last step that we'll do in these types of problems when you have those parentheses is we will have to get x by itself, by getting rid of the number that's with it. So I'm going to subtract that 10. Now here's the tricky part. On the left side, no big deal. 10 minus 10 is 0, it's just x. But on the right side, all right, this happened a lot with the quadratic formula, so I really want to make sure we focus on this. This 3 root 10 and this minus 10, those are not like terms, right? One has a root 10 and one doesn't. So we can't actually add these and say, oh, negative 7. No, can't do that. So instead, what we usually do is we just write it as an expression, right? Plus or minus 3 root 10 minus 10. But I don't like to put it on the end, because sometimes that makes us think that we actually can subtract. So what I like to do is I kind of slip it right in front of the plus or minus, and that's usually how we'll write our answers. So this would be negative 10 plus or minus 3 root 10. And I can't add them because they're not like terms. All right, so I would just leave that as my answer. All right, to show you one more example, take a look at number 6. So same thing, whatever's being squared is the part I want to get by itself. So that's just this part in parentheses here. So that negative 1/4, I'm going to get rid of it. Now normally when there's a number in front like that, a coefficient, we would divide. But since it's a fraction, hopefully you remember what we do instead, we're going to multiply by the reciprocal. So that would be negative 4/1, and I'm going to do it to both sides. Okay, that gets rid of our fraction. So it's just x minus 3 squared. And then negative 4/1, that's just negative 4. So 4 times negative 4 is negative 16. All right, now my squared piece is by itself, so I can square root both sides. And when I square root both sides, I'm going to cancel out the square, and I'm going to remember to put my plus or minus on the other side. So here we're just left with the x minus 3, and on the other side I have plus or minus the square root of negative 16. Now once again, simplify your square roots as soon as possible. So here, I know that that's going to become I root 16. And hopefully I also know that root 16 is 4. So that's plus or minus 4i. Now again, in these types of problems, it doesn't say x equals yet, so I still have that one extra step. I'm going to add the 3. But once again, this has an I, and this doesn't. So these are not like terms. So again, I'm just going to slip it right in front of the plus or minus. So 3 plus or minus 4i. And there's my final answer. All right, now just to make sure you recognize when using square roots would be helpful, take a look at 7. It says, can you use square roots to solve any of the following equations? Well, remember, square roots are for when there's only one x. So basically what I'm looking for here is an equation that only has one term with x in it. Right? Still a quadratic, but only one x. And right away in these first two, I see 2 x's. So the answers for these would be no. But letter C looks good because there's only 1x squared. So that one would be a clear yes. Alright, that's it for square roots. We'll do some more practice tomorrow, but for now, see what you can do on the homework and write down any questions you have. Thanks for watching and listening. Later.